Hi, my name is Theva Prasath, son of Mahendran. I'm from DKM 2A. My metric card number is 23 DKM 19F2002. Okay, today in this video I would like to do one of the experiment which is based on Charles law. It's from thermodynamics subject. Okay, later on I'll show you the apparatus, I'll show you the procedures, and I'll discuss about what are the questions are. Okay, so far that's all. Now I'll talk about the things we should need to do this to run this experiment, Charles law experiment. Okay, first of all, we need pail to pour the hot water and cold water inside. Then we need two balloons. One balloon is to measure with the hot water and another balloon is to measure with the cold water. Then we need marker pen to make a mark so that later on after the experiment and before the experiment we can measure the size of the balloon. Then we need measuring tape to measure the size of the balloon. Then we need timer. Timer is to calculate the size of the balloon after 2 minutes. So we should set the time for 2 minutes. Okay, so far that's all. Okay, these are the setups. Okay, here is the book to write the initial and end of the value. Okay, first of all we need to mark the balloon. Then you have to put inside the hot water or cold water to measure the size of the balloon after we put inside the hot water or cold water. Okay, then what else? The measurement of the water is tatap, so we can put how much we want. So like example, I'll put like 500 milliliter. Okay, then measuring. Sometimes the measurement will be different because we'll mark here. Then after we tube the balloon's measurement will be different. The marking will go up and low. So let's see how the experiment runs. So far that's all. Okay. Now we'll proceed with the first trial, which is with hot water. You can see the hot water, you can see the air all. Okay, then the timer is 2 minutes, and I want to let you know something, because after we put inside the hot water we should measure the balloon very fast. No, if not the balloon will go back to the normal size, because we had experience just now. So let's start with the trial. Okay, 1, 2, 3. Okay, let's see. I can feel the balloon getting bigger and bigger. Hopefully the balloon don't burst lah. Suddenly poop. Now the time left 1 minute 30 seconds. Okay, let's make the measuring tape ready so that I can measure the balloon very fast. Okay. Let's see. One minute left. The balloon is getting bigger. I can feel it. Okay. 30 seconds left. Ten seconds. 5, 4, 3, 2, 1. Okay, the time is over. Okay, let's go. Whew. The balloon expanded. I got 443.5 cm. It's equal to 435 mm. 435 mm. So the actual size was the initial size was 415, and after we put inside the hot water, I got the reading of 435 mm. So the balloon expanded. It's a great thing also. Okay, so far that's all. Okay, now this is the actual experiment. Okay, now I'll try trial kedua, iaitu which is with cold water and cold water. Okay, this is the cold water. Okay, I already set the timer for 2 minutes. Okay, then after we put the balloon inside for 2 minutes, then I should measure the measurement of the balloon. Let's see whether it expands or the size of the balloon decreases. Okay, let's start. 1, 2, 3. It's a long time. Let's see. Okay. We still got 1 minute left. Thirty seconds left. Ten seconds left. 5, 4, 3, 2, 1. Okay, let's check the measurement. Hopefully the size of the balloon decreases. Okay, let's see. It decreases. I got 37 centimeter. It's equal to 370 mm. Wait, okay, the actual initial value of the balloon was 415 mm. The final value is, after we put inside the cold water, the value is 370 mm. So basically the balloon decreased in size. It's a great thing. Okay, so far, okay, the experiment was done well. Okay, the data, the Nilai what I got was, for balloon 1, which is we put inside the hot water, was the initial size of the balloon was 115 mm. The final measurement was 435 mm. So the size of the balloon increases when we put inside the hot water. Okay, for balloon 2, with cold water, we tried with cold water. The initial size is 415 mm. The final size is 370 mm, which the size of the balloon decreases in cold water. Okay, now Okay, I would like to explain about I would like to talk about the statement of Charles' law. Okay, Charles' law states that volume occupied by a fixed amount of gas directly proportional to the absolute temperature. Okay, it's directly proportional. Okay, then what else? Okay, we should know that. Okay, you know why the balloon expanded just now? Because the temperature of the hot water transferred to the lower temperature air molecules inside the balloon. Okay, when this happens, okay, the temperature increases and the size of the balloon increases. The molecule inside the balloon, after we put inside the pail the hot water, the molecules inside the balloon, it starts to spread. It starts to move bigger and bigger, and it starts to spread lah. So it makes the balloon bigger. You know something, after we pick out the balloon outside from the pail, after few seconds the balloon will move to the actual size. It's because because there is no heat or energy inside the balloon after we take out the balloon outside, so the balloons will move to the normal shape. Okay, for cold water, you know why the cold water, after we put the balloon inside the cold water, the balloon decrease in size? This is because the colder the temperature, the closer the molecules inside the balloon. So this makes the molecules inside the balloon go closer. It makes like the energy inside the balloon go closer, so the molecules inside go closer and closer and closer, and it makes the size decrease. Okay, after we remove the balloon from the container, the molecules inside will gain extra energy from the air and return to the original size. That's what I can state from the experiment I have done just now. Okay, then the usual questions that they ask is why just now, like I said, why the balloon have expanded, and why the balloon is expanded when we put inside the hot water, and why the balloon decrease in size when we put inside the cold water. That are the usual questions. Okay, as I explained now, the cooler the temperature, the cooler the water when we put inside the balloon, the molecules inside the balloon will decrease. Not decrease, the molecules inside the balloon will move closer and closer and closer. This makes the balloon decrease in size. Okay, for hot water, when we put inside the hot water, the molecules inside that will expand. It will move around and expand. This makes the balloon expand. Okay, and other than that, that's all for this. Okay, I hope this explanation will help you, because I don't know how I explained, but I tried my best something. Okay, then that's all for Charles' law from me. Okay, thank you so much, and I would like to let you know that I tried my best to do the experiment. Hopefully the experiment went well and my explanation is quite good enough. So thank you guys. Please like my video and do whatever you want. Thank you so much.